Welcome back to Destination STEM Week, where today we're taking a look at how technology can be more sustainable. I'm here at the BP site in Sunbury, where I'm joined by Brett and Sarah. Hi, Brett. Hi, Sarah.
Good afternoon.
Good young people that we speak to in STEM education are very interested and quite concerned about climate change. Now, I understand that you guys are working on carbon capture and something known as CCS. Could you tell us what CCS is?
Yeah, sure. So CCS stands for carbon capture and storage, and it involves capturing CO2, generally from large industrial point sources like cement plants or power stations or other industrial sources. That captured CO2 is then transported to a storage site where we inject it deep underground into underground geological storage sites where it's stored and permanently removed from the atmosphere forever, effectively.
Fantastic. So Sarah, what is it that you actually do at BP and how are you involved with CCS?
Okay, so I'm what they call a subsurface manager. So that means I manage a team of geologists, geophysicists, engineers, and we describe where we're going to store the CO2. We find it, we describe it, we model how fluids flow in the rocks that we've found, and we demonstrate that we can put it safely in there and keep it there for the lengths of time that Brett's talking about. So for a very long time.
Amazing. And Brett, are you a geologist as well?
No, I'm a wells engineer. So my part to play is I design the wells and generally manage the operations and execution of drilling the wells too. So the wells are really important for CCS. They are the means to get the CO2 underground into Sarah's rocks effectively for storage. They're the conduit for the CO2 and we're normally drilling them several kilometers underground, so it's quite an engineering challenge as well to design and construct the wells.
And to put them where I tell him to.
Yeah. Okay. So how did you get into being a wells engineer? Is that an easy thing to suddenly crop up into?
Well, so my whole career I've worked in the energy industry. At university I studied mechanical engineering and specialised in mechatronics. So always had an interest in large mechanical systems, highly automated systems, which for wells, it really is a fantastic area to work in with the drilling rig technology. Modern day drilling rigs are hugely automated, sophisticated pieces of technology that we use to drill these wells. So it's always been an area of interest, and I stepped into it straight out of university.
So you're more interested in the rocks or the mechanical side of things?
Very much me, the mechanical side of things and the operational challenge of drilling the rocks, whereas Sarah is very much interested in the rocks themselves.
And I believe you've found some interesting rocks, Sarah. You got something to show us?
Well, so I have actually got a piece of rock. So the wells guys, the drillers, do go and they put holes in, but they will sometimes bring whole pieces of rock back to the surface for us so we can have a look at them. Because everything we look at otherwise, if you consider that where we're going to store this is a kilometre underground, we have to infer. So rather than being able to take pictures or whatever, we measure physical characteristics through putting electricity through the rocks or by putting sound through the rocks. So this is the one time we get small pieces like this, or we can get long pieces from where we're drilling, and we bring them back to surface, and then we can describe them and actually make measurements directly on them, and then try to characterize from these small pieces of rock 1,000 square kilometers. And that's where the understanding of the geology comes in, because you need to know, when was this deposited, how did it become a rock from being a beach or at the bottom of the sea.
Amazing. So this would be sedimentary rock then, if it's deposited?
Yeah, so that's the sedimentary rock.
And how old would this be?
So this is from the Triassic. And don't ask me how many million years, because although you've called me a geologist, I'm actually a geophysicist. My background is I'm an earthquake seismologist by background. So I have to ask my geologist how old it is.
And you spoke
but
about
it's many millions of years.
Oh, amazing. You spoke about passing electricity or sound into rocks.
Yeah.
Is that similar to maybe?
It's a little bit like doing an ultrasound. Yeah. So we shoot things we call seismic surveys. and we also do something that we call well logging. So we'll put tools down the wells and put sound into the sides of the wells to look, or electricity, to try to work out what's happening. But for seismic, we'll actually put sound waves. We'll put boats across. They'll make sound. They'll record that sound, and from that we'll process that and we'll make a picture. And it is just that, an image. It's not real. We've got to still interpret it, but it'll make an image of where are the rocks and what's it look like under the ground.
Amazing. So really exciting professions, I think you'll agree. But what is your background? How did you get into these roles?
So I'm originally from New Zealand, and at university there, as I mentioned, I studied mechanical engineering and specialised in mechatronics. And straight out of university, went into working for an energy company in Australia, and spent many years working on rigs there as an engineer on the operations and supervising the operations. And then in 2022, relocated to the UK and been with BP ever since. CCS, I naturally stepped into it, having for the first part of my career focused on oil and gas wells. I was able to move into CCS, where we're leveraging all the same skills and knowledge that I developed in oil and gas wells in the CCS world. So it's been great to work on the kind of forefront of the energy transition in the new role.
Fantastic. So you've moved over to BP. Would you say it's quite an international company? Do you work with other international companies?
Yeah, absolutely. Generally, like other energy projects, we work in joint ventures with other major operators around the globe. So yeah, BP works with the likes of the other majors in developing these projects. And in my role in particular, I also support BP's global CCS portfolio. So I'm every day talking to different parts of the world, trying to help solve their problems and challenges, which can be unique to the region and to the area.
Amazing. And Sarah, what's your background?
So my background, so I'm a scientist. So I did science A levels, and everyone said, go and be a teacher. And I was actually, I want to apply what I'm doing in terms of science. And so I went and I looked at universities, and I had no idea what I wanted to do. And one day I stumbled across, I kind of want to do geology, but I want to do geology and maths. And everyone kind of looked at me as if I was completely mad. But there's this subject called geophysics. And geophysics allowed me to explore my passion for earthquakes, volcanoes, rocks, just being outside and learning more about how does our world form and how is it developing. I've always been fascinated by the oceans, but I get seasick. So it was never going to be me floating around on a boat in the middle of the sea. So I found other ways to kind of explore that. I studied earthquakes and got a PhD. And then I joined BP, and I've done all sorts of different things since then, from planning wells and executing them with drillers to developing fields, trying to understand. Basically, I love solving puzzles. And there is a new puzzle to solve in this industry, be it CCS or other, every day. And I've now been doing this for over 20 years, and I still find new challenges. So, and that's what I love. I think if I knew exactly what I was going to do every day coming in, I wouldn't want to do it anymore necessarily.
I need to ask you, for those young people that might be watching, are there any initiatives, are there any clubs that they can get involved in if they are interested in rocks or fossils or geology?
Just say yes to things, go out, have a look. You don't have to go and do anything in particular, but I would encourage you, you've got to like to be outside, you've got to be curious, walk along your beach, look at what are the patterns on the beach. Do geography. That might be easier to get than geology at school, but you can do that. But make sure that you've got some science as well, because it's not just you need, if you've got the basic sciences, you can build all sorts of things from that. And you know, we do modeling, so we use computers. We have to be computer literate, be able to program, be able to build digital models. So there's such a range of things that you can do. But the thing I've always loved is it's science in the real world. You can see an impact, and you can see an impact pretty quickly as to whether what you're describing makes sense or not. And we look for modern analogues, so understanding how the modern world looks and how it changes is as important as going and having the understanding of the fossils initially if you don't have access to that.
So there we are. Even geologists need a very good understanding of IT systems. So Brett, what skills do you need to allow you to do your job?
Wow, for my job, it's a lot of problem solving every day. So being able to kind of think laterally and outside of the box as well, particularly with CCS, it's really a new and developing industry and area. And we're seeing problems and challenges that we haven't come across before, and we're looking at developing new technologies to solve those problems, or slightly deploying new current technologies in new ways to kind of help solve those problems. Like Sarah said, definitely, IT skills. We're building really sophisticated computer models of the well's construction and then ultimately their operation to help inform the engineering design. And that generally involves some form of computer programming and kind of various languages and things, but often just being able to kind of interact with the various software packages and being able to kind of manipulate them to achieve your desired outcome is really important. Like with, I think, any engineering discipline, we do a lot in Microsoft Excel. If I could recommend one piece of software to become very familiar with, it would be Microsoft Excel. We use it for almost everything, from really complicated, sophisticated engineering calculations to our cost estimates for the project. So it's
what's your favorite function in Excel?
Probably an index match.
An index match. I've not learned that one yet. You're one step ahead of me.
I'd add to that, though, it's not all about just being able to do the technical stuff. You've got to be able to explain the technical stuff. So an ability to draw a picture to explain to somebody who doesn't do what you do is really important. The ability to explain in relatively simple terms what you do to somebody who is trying to make a decision and needs your input, but doesn't need to understand everything that you've studied for the last 10 years is so critical. So if nothing else, I'd say, you don't need to be able to write really, really technical documents. That will help, but you do need to be able to explain what your thinking is. You can be wrong, but it doesn't matter if you can explain why you think that's a reasonable outcome.
That's really interesting, because I'm a former science teacher, and I would often say to my pupils that it doesn't matter if you're right and wrong, so long as you can explain your reasoning. And quite often scientists are having arguments amongst themselves, and it's those with the best evidence who actually win that argument, as it were.
Yeah, I mean, everything is a theory, and the point of a theory is not to necessarily have exactly the right answer. It's to have an answer that you can explain and that others can challenge to make it a better answer. And to also know, where do I need to go and get more information to make this a better answer and to give myself more confidence in it. So understanding that you can be right enough, but you can still want to get a better answer is a great way to be.
Amazing.
Yeah. So those communication skills too, having the ability to take 6 months of really technical work that you've done, and you may only have 5 minutes to deliver it to a key stakeholder, a manager or other partner in the project, and convince them of the outcome of that technical work. So having the ability to condense huge amounts of information into small, digestible pieces of information is really critical too.
Yeah, and it might seem that we talk to people all the time, but I remember being at school and being absolutely hating presenting anything to anybody. I'd go bright red in the face, I'd stammer, I loathed it. And it's only through having to do it and doing it in a supportive environment, such as we find here, that actually you grow those skills. So don't think you need to come in being able to do all these things. You just need to show that you're willing to give it a go and take a risk.
Amazing. So you two must have been to some really interesting places. What's the coolest place you've been to with work?
Well, I'd have to say I worked for quite a while in the Australian outback, in the literally in the centre of Australia, and a fantastic place, just an amazing landscape in the desert. Quite challenging though, where the temperatures get up to 50 degrees in the sun, or 50 degrees in the shade. Actually, it's an extreme place to work, but a beautiful place.
So I worked in Azerbaijan, not long after the former Soviet Union had collapsed. And it was an amazing place. It's a place of so many different cultures, many different climate zones. And you could go from the desert to the mountains in about an hour. And it was just amazing to see somewhere that had so much diversity and was somewhere I had no awareness of before I went there.
You speak Russian?
I did have to learn some Russian, so yes, not just content with needing to be scientists, we also we were provided with language training. So yeah, Russian and then French, because I worked in West Africa as well. So
a real polymath.
Yeah, I'm not sure. I don't think anyone would necessarily recognise it as that.
So obviously you've been around the world, but you're now working on the UK CCS project. Where is that based?
So the UK CCS project we're working on is based out of Teesside and Humberside, capturing industrial CO2 and piping it offshore to the southern North Sea, which is an area where we've been producing gas as a country since the 1960s. So it's a big project. It's called the East Coast Cluster, and it'll be one of the first, or the first in the UK, to start putting in practice CCS on a big scale.
So there we are. Any young people in Teesside that are interested in geology, very exciting prospect coming up. So what are you looking for when you're trying to find somewhere to capture carbon? What are you looking under the sea for?
It's probably one more for Sarah. I just drill where she tells me to.
He just goes where I tell him to. So what we're looking for is we need to have a reservoir, what we call a reservoir. So it needs to be a rock that has holes in it. We call them pores. So they need to have porosity. Those are the holes. Then it needs to have permeability. That's how the holes join together. And what we do is in that porosity, normally there's either water or gas or oil. And what we do is we inject CO2 and displace what's in there currently and replace it with CO2. So down the wells and out into the rocks. And then we need to make sure that that CO2 stays in that rock. So we'll be looking for what we call a trap. So that's generally can quite often be structural. So we call it an anticline, but you might think of it as a bit of a hill underground or an upturned bucket kind of shape, so that it doesn't leak out the sides. And then we make sure that there's something which doesn't have any holes in over the top, so it doesn't go up, because CO2 is buoyant, so it wants to go up all the time. So we put it in and then make sure it can't go up and out.
And it's just rocks we can trap gas in, or are there other options? I think you were talking about old well sites before.
Yeah, it's still targeting rocks, effectively storage reservoirs, but there'll be a common CCS play is a depleted oil and gas field. So a field that we've produced for many years, the hydrocarbons, be it gas or oil, generally gas for CO2 storage. Now those fields are effectively depleted or empty. They're no longer producing gas, and we can actually go back into those fields and inject CO2. We know they held hydrocarbons for millions of years, and we'll know that. So therefore, we know that they will safely hold CO2 for another, several millions of years. So they are very good CO2 storage targets too.
So young people have been hearing a lot about net zero, particularly from our government. How can CCS contribute to these net zero goals for the UK?
Yeah, so there's two main clusters at the moment, two main industrial clusters that are progressing with the government to start injecting. They're starting relatively small to start with, because we need to prove that we can do it, gain the confidence. but potentially the East Coast cluster, so the one in the northeast of England, could capture about 50% of the industrial CO2 from the UK in the future. So these could be really big projects and make quite a sizable difference. They contribute through, obviously we want solar, wind power, all the other renewable types of power, but we also need to have what we call baseload power. So we have a power station, but rather than just venting the CO2 from that power station, we capture that CO2 and store it, which means that you can have power when you need it, but without creating CO2 emissions.
So a combined effort of looking at renewable energy, but also how to almost retrofit classical energy.
Retrofit or build new efficient ones that can provide that in a way that allows us not to make an impact on the environment.
Amazing.
And some of those sort of hard to abate industries like cement production, the chemical reaction involved with cement production releases massive amounts of CO2, and there's no real way to make it without that CO2 being released. So if you can capture that CO2 and permanently store it underground, you can make a low carbon cement. So that's another really key target for CCS technologies.
Fantastic. So just to finish up, I'd like to ask both of you what your overwhelming achievements are, and also what the overwhelming achievements of BP have been of late.
That's a big question.
That's a big question. Well, I think, particularly proud of the work I've done recently on the NEP project, which is part of the East Coast cluster that Sarah and I work on together, taking that project through its kind of final feed stages.
Yeah, so I love solving the puzzles and progressing NEP, but I also love working with quite a big team and seeing people do things and achieve things that they never thought they could when they came into the team. So giving them those opportunities to do stuff, to try stuff, and to do more than they ever thought was possible is just that's the thing that gives me the buzz.
So Brett, we've spoken about current projects with CCS. What does the future look like for CCS and any other technologies that are coming through?
Yeah, absolutely. So CCS, there's huge potential globally going forward. There's currently around 45 operational CCS projects in the globe currently injecting CO2 at with a combined injection capacity of about 50 million tons per annum of CO2. The IEA, International Energy Agency's path to net zero by 2050, a big part of that is CCS technology. And by 2030, we need to be injecting about 1,000 million tons of CO2 per annum. So there's a huge gap there between what we're currently doing and where we need to get to. There's been a lot of projects announced in the last couple of years. The current announced pipeline of CO2 injection capacity is around 600 million tons, but there's still a gap to get to that 2030 target. So there's going to be a huge amount of projects in this industry in CCS, lots of opportunities for jobs, and it's a great industry to be working in, I think.
Fantastic.
Still hugely developing, and when I look at how much it's developed, even over it's been long and slow, but over the last 5 to 10 years, just the scope and scale and how we're going to do it is accelerating. So I think really exciting place to be.
So another important aspect of CCS is it enables low cost, low carbon hydrogen production. And hydrogen is critical for a low carbon economy because it can help you decarbonize heavy industry, things like trucks and shipping, huge shipping container vessels, which can be powered on hydrogen, emission-free hydrogen. So CCS unlocks the potential of that low carbon hydrogen industry.
I did actually get to see a hydrogen cell in a canal boat somebody had fitted a hydrogen cell to. So yeah, real cutting edge technology that you guys are working on. I want to say a big thank you to Brett and Sarah for your time today. Really eye-opening stuff. For those of you who are interested in carbon capture technology and would like to know more about what BP are doing, you can visit the Energising Futures website, where there are lots of job roles that are explored there. Again, thank you, and I hope everybody has enjoyed our discussion today around sustainable technology.